My name is Chiara Cicobello, and I work as a data scientist at AI Sweden, but I'm also the coordinator of AI Sweden's space activities. So I'm going to talk about that today, especially given the particular focus of this meeting. I will focus on, of course, on the activities that are centered on decentralized AI. Why space? Well, I think you're always witnessing, as I am, the exponential growth of the global space economy. And we can see that by the increasingly large number of satellites that are launched every year, as you can tell here. And this is due to the fact that the cost of manufacturing and launching of satellites has been plummeting. So we are now having entire constellations of satellites going around Earth. And then, of course, is the perfect ground for us to study and investigate how decentralized learning can be used in this kind of circumstances and in the space domain. Now, if you think about like every single dot, we can look at it from the perspective of the data generation. So if we think about, for instance, Copernicus Sentinel-2 satellite, which is one of the most well-known satellites that collects images of Earth, well, Sentinel-2 takes about 20,000 images of Earth every 5 days, which accounts to 1.6 million per year. So this is we're talking about big data. And if you think that each dot is more or less collecting the same amount of data, you see that we have, well, a problem in the sense that this data has to be moved around in order to be analyzed. And this is a very complex type of data that requires pretty heavy pre-processing before even you can get to do anything with it. However, because we have so much, this data has invaluable value for many different kinds of fields. So we can use it to get information about climate. We can use it for navigation, for satellite communication, for monitoring of land use, water, forests, and so on. So it is really a source of knowledge that we want to harness as best as we can. However, like I said, there exists a very big problem that is only going to get worse with time. The data has to be moved primarily either from the ground truth to the satellite in terms of commands and things like that, or back to the ground when we want to actually download data. And also we want to ideally also communicate between satellites depending on what we want to do with them. And if you look at the full radio spectrum, then you see that there is only a very little band that can be used, that is given for satellite communication. And within that, only just very, very little bands are given for satellite communication. So you see that, like, if we send in orbit many more satellites, we soon will get to a point in which we have a problem with communication that is very serious. So we want to become very efficient in doing so. And as we heard so far, we can maybe use decentralized AI to partially postpone this problem at least, and try and see if we can be better at it. We can use all the knowledge that we can gather here, for instance, at AI Sweden, from all the other fields that we are working on with the same type of technology, and see how we can use that in the space domain as well. And we heard just now that even when you have a lot of clients interacting with each other that do a lot of transaction, there are like they vary over time, like for instance, satellites that don't see each other all the time, or they don't see the ground station at any moment, can be as well transferred. And that what is that is our goal. It is actually one of the main focus that we have here in one of the project that we are that we have. Oh, what happened? Sorry. Here, that we have together with Unibap, which is a company that develops hardware and software for setting up a space-based application on board of satellites and help them set up smoothly and maintaining them and operating them. This project is financed by Remi Stidelsen, and together with that and the enormous help of like young talents and my colleague Rasmus and another from AI Sweden, we are testing a number of models that are suitable for many different types of applications, like, for instance, change detection or like monitoring of forests or cloud detection, and even space interferometry. So what we are doing is testing this different AI models in the lab here on the Unibap machines, and see how would they interact with each other if we set up like the AI training and inference like on decentralized setup. In order to be as realistic as possible, we are also using a tool that we developed with ESA last year, which is called Paseos, and it's a simulation tool that simulates multiple spacecraft orbiting at the same time and exchanging information, optimizing both, well, studying power consumption and trying to optimize communication between them. So what we are using this tool to like in conjunction with several different kinds of models to see what we can do about it. Then, as an overarching space project, I would say, especially focused on the Swedish space data users community, we have a project that is ongoing since 2019, of which AI Sweden has been one of the core components since the beginning. And it is financed by Vinnova. The goal of this project is to lower the barrier for space data usage. So what we want to do is to create data-ready, analysis-ready data, so that we can provide them to a broader community that doesn't need to do these steps individually. And by doing that, we hope that more users will be joining this community, and we can have like a much better connection and a lot of use cases to work on. Most of the apps that are developed under this type of project, but specifically also this one, are focused on are using decentralized AI, and among them we picked two that you might be interested in, and we created these two posters. And when I say we, I intend me and Rasmus, who's going to talk just right after me. One is the one in which it is like say focused on a specific technique for astronomy that is called space interferometry, where we aim at reconstructing a sky model using AI and a decentralized learning setup. While the other one is in collaboration with ESA and the University of Cambridge and Unibap, of course, where we want to test a smaller version of the segment anything type of model. So we want to do image segmentation with a very lightweight model, also on board of satellite, and benchmark as well the power consumption and so on that we will end up having with the use of this model. Yes, so this was it. I really hope that you are a little bit curious about what we do in space. And so please come and talk to us. We will send him close to the posters. Thank you.